this. And the other one is the second formula, the square root. I'm having trouble to enter it into my computer, my calculator. I think this one I understand a little bit more better than the last lesson.
Right. Hang on one second. I'm going to do something real quick. Because to me,
10.
I was looking at this and saying, like, this is something that we should be using Excel for, like, so much. I mean, this is just such an Excel type of a lesson, at least in my opinion.
And I'm trying to get a scientific, I probably need a scientific calculator. I got this calculator and I'm having trouble sometimes. Sometimes I'll get it right and sometimes I don't. So. But that's what they asked you for accounting. So now enroll. Okay, so we're ready.
1 sec. I'm just doing something really fast. Then we'll do it.
Oh. Thank you.
Nope. Did I open my exam? No, I did not. Silly me. I'm a quiz. Yes, sir.
Right. I don't want to work that shed.
Probability.
Okay, it's not going to work. I'm not going to do this. Do save.
Where's my calculation? 16.
Okay. So we all could look at the, we're all looking at our own quiz, but I'm going to bring up and just kind of show my Excel stuff. So margin of error, standard deviation, and we have our N, the sample size, right?
Okay. Remove the baking sheets in there if you want to warm that up. Thank you. My husband and my kid is still off under fall break, and so it doesn't help me. When they're home, they bug me all the time.
I
So.
don't know if you guys have seen this, but you can use, so there's one way to do this. So you can do, here's a confidence deal in Excel. I don't know if you guys are looking at my page right now.
Yep.
So it's asking for three things. So the alpha essentially is 1 minus the percentage of error. So like in this case, so it'd be 0.1 is your first thing because it's 90%. So 90%, 0.9 minus, or 1 minus 0.9 is 0.1. So if it was 99, it'd be 0.01. Does that make sense?
Yeah. Uh-huh.
And then the second thing it's asking for, if you can see, is the, I don't know if you can see, it doesn't look like you can see, but standard deviation is the next thing. So our standard deviation is 50. And the last thing, it's asking for a sample size. If we go to 25, this should give us our standard or margin of error. The other way,
450, yeah.
The other way we can do it is, so if we want to look at this, I guess I'm going to do it by hand as well, right? So our standard deviation, 50, and
Sample size 25.
Okay, so who wants to go over the equation real quick?
The equation is.
I have it in here somewhere. I'm just here.
Is that the M equals 2 over, is that one?
Well, we're just doing question 3 right now, right?
Yeah.
So
X is hold on, let me see.
I watched all the videos on it, and they make so much more sense. Then I go back to the text, and I always get lost at where everything's at.
I watch the videos, and but when you read the text, and it messed you up more than the video. So.
Right. Yeah.
So the formula.
Margin of error.
Confidence interval. This equation gives confidence interval. I'm not sure if that's the right one. Because the formula is, this is the other one.
So we don't have the value of z, right, yet?
No, we don't.
So it's not one of those equations.
So it's just the it's the 2 times 2, what do you call it, with the standard deviation
times standard deviation over the square root of n.
Square root of n, yeah.
Okay, so if we say, okay, so we go in here to our equation, and we say, okay, the equation is going to be, oops, I'm clicking on the shared screen instead of the actual, there we go. So we're going to say 2 times, and then we're going to go our standard deviation, right? Divided by the square root of the sample size.
Square root of 25 is.
Right, so we go, the square root is
5.
times 0.5 is a square root, right? Oops, that didn't work.
So the square root of 25 is 5.
Right, so 50 divided by 5 would be 10. So
times. So 20.
So, and then 50 over 10, or 50 over 5. It's giving us 2, but that's not really, I mean, this.
Isn't it the, oh, hold on, let me see. It has, it gives us a margin of error. So let me see.
Oops. That's saying 20. That's not. See, I don't know if the two, but you know, we should. Where's our margin of error in that equation? Where's our 0.9 in that equation? So I don't think we're using the right equation, right?
Yeah, let me go look back and see which one is the with the margin of error. Margin of error.
So the 2 is like if you have 2 standard deviations. I don't think that's what that's the distribution of sample means.
So don't we have to put the
Z. Margin of error is equals to Z. Oh, hold on. Z times that. Of equation that is added into the subtract x is called margin of error.
Don't we have to get the z-score?
Margin of errors is equals to Z times standard deviation divided by square root of n. Oh. No, that has that. Hold on.
Because you're talking about Z times.
Hold on.
Right? Is that what you're saying, Sam? Is we need to be doing the Z times instead of just using the number 2. We need to use the Z-score times that number. Yeah, I'm totally having a brain fart. Okay, so how do we get our Z-score again with this information?
If I'm remembering right, I think you put in the what is it saying? The confidence interval into the probability spot, like in the applet, and I think it gives you the Z-score if you put that in.
So you're saying we use because they do say use the normal probability applet. So if we open that up, you're saying use 0.9 on the area.
In the
on the top, and then whatever is in between, in the middle.
Is 0.126, and we'd say instead of number 2,
1.65.
we're going to go here, and that. Oops, did I do that wrong?
Is it 1.65?
It's just saying times 10. So are we saying it's 1.26?
Oh, 1.65? Oh, hold on.
I'm getting a Z-score of 1.26 or 0.126. So if you plug it into our little equation here, then we get this 1.26.
Point 900, and the middle part of the applet is 1.645.
I'm not following here.
Because in order for hold on, let's see.
Oh.
The level of confidence is
Was the middle spot?
Yeah, the middle, the middle of the 2 lines.
Okay, so I got 0.1003. Is that not what you got?
No.
So go back to the applet again.
Okay, let me finish, reshare this here. I'm going to just do the screen too, share that. And that way I can show different things as I need to. Okay. So like here's the applet. Let's reload the applet.
So keep it shaded in the middle and then so shade it back in the middle again.
Right, and then you say like that. That's what
0.9?
But now change it back to 0.9 up top.
Yeah, I don't think you can at this point. Here.
And then there's the 1.645.
That's what you're saying. Okay.
Mm-hmm.
So then you would say over here, but that's just going to change this to 1 point.
Well, that's gonna, if you put that in there now, it's gonna be the 16.4 something or other that we have up there in F.
Okay, so now they match.
Yeah.
Mm-hmm.
Okay, but we want this now to go to 3 decimals, not 2.
So that's
So
16.449. According to
16.4.
according to Excel, which I would trust more than my basic math skills.
Yeah.
What do you mean? Yeah, come on. You trust my.
I mean, your math skills are way better than Excel.
You're supposed to round it off, isn't it?
3.
So what's the score again? 16.
16.449.
So that's going to be 16.450.
No, 16.449 is rounded to 3 decimals.
Oh.
That's from what we did in Excel.
Because if the fourth decimal is a 5, so it was 4485, so it's 449.
Okay.
Yeah.
When I was doing this on, I think it was like Friday or something, I was like, man, this is so easy, and now I've forgotten everything.
Right? Isn't that how it works? Okay, which of the following statements is true? That the standard deviation squared is the interval estimator of x bar. X bar
is a point estimator of mu.
Yeah, that's what I was thinking too.
Next. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a sample of 64, and she knows X bar is 526. Use this info in the next 6 questions. What is the point estimate for the true GMAT score?
The point of estimate is the X bar. Is that right? 526?
I think that's right.
The confidence interval is actually the point of estimate X bar plus or minus the margin of error. Well, the point estimate is the X bar. So,
okay.
Yeah.
So we're at 526.
Mm-hmm.
What is the margin of error of the 95% coefficient?
27.685.
You already calculated
That's on
that.
my calculation. I'm not sure if I'm right.
So let's look back at Excel and take a peek here, right?
Confidence interval for the true GMAT score.
So if we're looking for the margin of error, that's going to be the, is it this? No, it's not this guy. Sorry.
Alpha is.
Okay, so that's going to be, that's the 2 over, or 2 times, right?
Let's see.
The size is.
It's the 2 times the 113 divided by the square root
Of 64.
64, and I need to put an equal sign or else this is not going to do us any good.
The wrong one.
28, what did you have?
27.685.
Okay, we're having different numbers here. Look at what numbers I have. I have 2 times 113 divided by the square root of 64, right? Is that what you have?
Yeah, but I just did it. No, I didn't do it on Excel. I just did it on my.
No, I get that. I'm just making sure we have the same formula.
Yeah. Is that the 1.96 times 113 divided by square root of 64?
So we're doing 1 point. Sorry, that's where I'm getting 1.96 because and we get that because of the 95% thing, right?
Yes.
Yeah.
Okay, so that's the okay. So 27.685 is what you got.
Yeah, that's what I got.
Okay. Now we're on the same page.
This is weird. Number 6 is the only question that doesn't say how many decimals to round to. I would assume it's 3, but I don't know.
They did that on the test too, the exam. They didn't tell you how much to round to or anything. It bugged me.
That one is the lower one is 498.315 is what I got.
498.315.
Yeah, because you have to read the minus and the plus. So.
And that's 526. So you go right?
526 minus 27.685.
And the other one you add.
The other side you add. The higher part you add. The lower part you.
So the upper limit is 553.685. Yeah. Okay.
Do we have to round that off?
That is rounded.
Okay.
At least. Yeah. The next is 0, so it's 3 decimals anyways.
553.685.
Yeah. What would happen to the width of the confidence interval if Gina increased the sample size?
It would decrease, right?
Yeah, decrease. According to the video we watch.
What would happen to the width of the confidence interval if Gina changed it to 99% interval? Confidence interval would increase, decrease, or no change?
I don't remember on that one.
I think it increases.
Increase?
Uh-huh.
Okay. Oops.
Okay. Number 11. Where did I? Where's my calculation on that one? Just be quiet, please.
Okay, Bright Bulb Light Bulb Company. Planning average standard deviation is 400. They want a 95% confidence with a margin of error of 50 hours. What sample size do they need? Rather than full number, if you get 101.2, blah, 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 yeah. What sample size do they need?
So they need 1.96, and then 400. The 50 is the n. So we have 1.96 times. You gotta square it, this whole formula, isn't it?
Not square root, square. Don't you have to square the formula, not square root it?
I think this is the one that's in the bottom, the very bottom of the formula. Hi guys. Divided by.
Yeah, z times the deviation over m squared, right?
Mm-hmm.
Not square root, but squared.
Squared, yeah, that's what I mean.
So do we have the z-score? No, we don't have the z-score yet, right?
So that's where we need the applet again, right?
Okay, so I have the applet. So do we do the middle ground again?
Uh-huh.
Oh wait, the 95%, that was just 1.96, right?
Yes, uh-huh.
Yeah.
One thing that's good with this one is that those are fixed. Your level of confidence are always fixed.
Yeah.
1.96 times 400
divided by.
What are we dividing by again? M?
50.
50.
And squared.
And then we're gonna put all this together and then square it all. 245.862.
Uh-huh. That's what I got.
We need to round to the nearest whole number.
That's right.
So 246.
46.
But they always say, and just remember, round up no matter what. So it's always up. 246. Thank you for catching that, Sam. And then, okay, the mean salary of actuaries is mu of 100 grand. Standard deviation is the 36,730. And the A is 0.05.
So that we do the same thing, the equation that with the C minus, whatever that is, the x bar minus the z times standard deviation over n,
Right.
square root of n.
So we're still at the
And that's what's on the other
1.6.
side.
So we're doing, instead of 113, we're doing 36,730 over the square root of
36.
36.
So I got
11,998.
yeah, 11,998, but
That's the that's just the margin of error.
margin of error, yes. But they're asking the lower limit of, so we have to minus, take that away from 11,000.
100 grand. So $88,001.53.
Isn't it the 11,
Oh, nearest.
111?
You said the lower limit, didn't you? Isn't that the bottom? So you have to subtract.
You have to subtract it from
Oh, from 111, not from
111 at 100,000.
Oh, I'm sorry. 111 grand. Okay, so 98 and $2. Right, 98,002.
Yes.
Did I do that all right? Hold on. Mine is 99 somehow. Hold on.
In the upper.
Okay.
Is 121,999.
Yeah.
Right. Well, right. It says round to the whole nearest whole number, but do we round down on this one or round it up? Because it's not. We're not talking about a sample size, so we don't have to round up, right? Don't we round it to the right number?
Round to the nearest whole number.
Yeah.
Shouldn't that be 97?
Or 98.
121,998.4.
121. So it's 122. Oh no.
No, 121,997, right?
Would it be 7 or would it be 8?
Well, but it would be 7 because we're not talking about sample size. Sample size, you always have to go up.
Right, but if you're rounding down, it's just dropping the 467 and becoming an 8.
Or that, yeah, sorry. So 8, not 7, excuse me, but yeah, not 9, right? Because we're not going up, we're just going to
Right.
Yeah, so 121,998.
121,998. Okay.
I'm having that day today. Okay.
It's a Monday.
Well, and that's always, you know, in math, I was always quick in math, but that's how it always get me is like I just like blow through something and do stupid stuff instead of like. Okay, there are 3 requirements that need to be checked when computing a confidence interval for a mean.
All of the above.
That's kind of a really funny question. It says there needs to be 3 things. Is it one of these or is it all 3? It's like let me think.
Go with all 3.
I think
All
yeah.
of it.
But by definition of the question, none of those can be right.
Exactly.
Yep.
That's bizarre. It's kind of a really poorly worded question. All right, let's go see if we're as smart as we always are. Oh, we missed one.
Which one?
Missed the upper and lower limit of 12 and 13. Which are,
Isn't it 99 point? Let me check mine, okay?
I had 98.
I came up with 99 though.
What number are we talking?
12 and 13?
I can flip those up.
Okay. 12 and 13?
Yeah, they're both worth half a point.
Oh, okay.
See, I got 99.9900 rounded up to 2. Let me check mine, okay? Let me submit mine. Did you put a comma on it?
No,
Or just
no comments.
122,998? Let's see.
Dad, my hand was literally, middle finger, ring finger, and index finger were covered in paint. You couldn't even see my skin. Because
What number is that? I got it right.
It was 99.
99, 002 and 122,998.
Well, you should have mentioned that earlier.
No, I was saying earlier that it was, I came out with 99.
All right, so you guys got that. I'll survive with a 93%.
Oh, you can
Oh, I think I
resubmit
typed
it. You can redo it. Yeah.
Oh.
This one, if you redo it, it will not do the average. It's whatever the highest.
Oh, cool.
So,
All right. So are we meeting again Wednesday night then?
yeah, we're good for Wednesday night.
Sounds like a plan.
Sweet. All right, guys. Well, have a good night.
Oh,
and
you
we will,
too.
chat with you on Wednesday.
All right,
Yeah,
good night.
I'll remind Mr. Gavin Brown.
All right.
Sounds good.
Okay.
Bye-bye.